Well, it's Friday. We're glad about that. We're gonna have a good time this weekend. So let's get started with today's work. So today we're gonna start off with 7.4, just a particular topic in 7.4. In fact, just a particular way to solve a particular problem in chapter 4. We're looking at geometric mean, and chapter 7.4 is a right triangle similarity section. So now we're going to look at one triangle that we split into two separate triangles, which we looked at again in a previous chapter of how to separate one triangle into two, so that you have, into three in general, the original one and the two new ones that you're splitting it into. But we'll talk about that on Monday and Tuesday. But today we're just going to talk about how do you calculate that line that you drew to create the three triangles. So the agenda today is to specifically talk about geometric means. On Monday and Tuesday, we'll talk about altitude, even though I'll bring up the word altitude today, and then sketching similarity triangles on Monday and Tuesday. I think we do like 3 problems today, and you'll have 4 or 5 to do. Geometric means. Use geometric means to find the segment length of a right triangle. The segment length is that line that you draw from the right angle portion vertex of a triangle to its hypotenuse. So, and that length is to calculate it is defined as the positive square root of the product of two numbers. And basically, we're back to ratios again. What does the geometric mean between two numbers? So say you're given 2 and 8, and we said it's the product of two numbers. So that means we're going to multiply the two numbers. 2 times 18 gives us 36. And then we're going to take the square root of the two numbers to get the square root of 36 is 6. So the geometric mean between two numbers is 36. Is 6, excuse me. So how do we end up with a ratio if we just take in two numbers? Well, now when we're looking at the two triangles, we have to set up ratios. So the mean proportion of A and B is the value X, where X is that value we calculated a minute ago, which was 6. So A, and the way you say it is A is to X as X is to B, which is how you talk about any ratio. It looks hard, but we know how to solve this. We cross multiply and then we divide or square root. So let's look at a problem of how to do that. We looking at that 2 and 18 again, but now we're looking at the mean proportion, not the geometric mean, or it's the same thing as the geometric mean. But you'll see in some books it will say mean proportion, not geometric mean proportion. You just have to know to set it up in this ratio. So that means that the x has to be in the numerator of one and the denominator of the other. It really doesn't matter. We could have went 18 over x equal x over 2. We could have did that. But in this case, we did set it up similar to what we had before. So 2 is to x as x is to 18. And we multiply the two numbers, and then we take the square root, and we end up with 6. And obviously these two ratios, 2 over 6 is the same thing as 6 over 18. If I reduce 2 over 6, I get 1/3. 6 go into 18 3 times, so 6 over 18 is also 1/3. But that's not what we're looking here. But if you're ever nervous about your answer, the ratio should reduce to the same number. Geometric mean in a triangle, which is what we'll be doing on Monday and Tuesday. So when I take one big triangle and I split it into two, I'm drawing this line from the right angle to the hypotenuse. And it's not splitting the hypotenuse into two equal parts, but it is splitting it up into what we consider a left and right part, or whatever you want to call it. So when we're setting up the geometric mean, or the mean proportion as we did in the previous one, notice that the triangle on the left side, the word left is on the long leg of that triangle. and the altitude is on the short leg of that big that triangle. If you look at the triangle on the right that was created, the altitude is the long leg of that smaller triangle, and the word right is the short leg of that triangle. So we set up the ratios where the left, the word left, and altitude, well, left is the long leg to the triangle on the left. I hate that they use the same word that I'm trying to use. And altitude is the short leg of that triangle, so it went long leg over short leg. You could have also went short leg over long. Whatever you do, you have to be consistent on the right side. So on the right side, the long leg is not the word right, but the word altitude, and the short leg of that smaller triangle is the word right. So now we have our mean proportion. And if we wanted to solve it, we cross multiply by multiplying left times right equals altitude squared. And then we take the square root. So I just wanted to do number 2 out of the handout. And I recopy the diagram from the previous page where we have left and right and so forth. In the triangle above, you can almost look like it's flipped over and turned to the and rotated. But let's look at how we would set this up. The triangle on the left, which is ABT, the short leg is 5, and the altitude or the long leg is 10. So I went 5 over 10, short leg over long leg for triangle ABT. For triangle ATN, the long leg is X and the short leg is 10. And because we already know the altitude, we're not finding the altitude, because remember the geometric mean is finding the length of the altitude. They already gave us that, which is 10. When we set up our ratio, in this case, we already know that word altitude in the diagram below. We already know that's 10. So we go 5 over 10 equals 10 over x. We can actually go x over 10 equal 10 over 5, as long as we keep the altitudes on opposite sides of the numerator and denominator on the opposite sides of the equation. We cross multiply and we get 5 times x equals 100, and we divide by 5. We did not have to square root, because you only square root when you're looking for the altitude. We already have the altitude. Let's look at number 7. 7, I'm going to set up by the label of the points of the line segment first. So SR is my altitude. SP is the long leg of the triangle that's formed by the altitude on the left. QS is the short leg of the triangle formed on the right by the altitude, and then the altitude is SR. So then I label what each of those segments mean. SR I'm going to label as X, because I'm looking for the altitude this time. And this is problem number 7 in that handout. And then SP is 12 and SQ is 4. So now I'm going to replace the letters that I have with the information that I know. SR is X, SP is 12, SQ is 4, or QS, it doesn't matter which way you do that, and SR is X. I cross multiply and I get 4 times 12 equals X times X. X squared equals 36. And then my software doesn't do the square root symbol, so the square root of 36 is 6. So that's the length of the altitude SR. 28. So I can simplify it to be 2 times the square root of 7, or you can just simply leave it as square root of 28 for my class right now. So that's all I wanted to talk about today. I know it could look difficult because I don't have my math symbols. Apologize for that. But anyway, finish the worksheet, turn it in no later than Monday, and have a good weekend.